Chapter 3, Section 2 is about solving multi-step equations. So by the end of this lesson, you should be able to use the distributive property when combining like terms. You should be able to use the distributive property when solving equations, and you should be able to do something called clearing fractions and clearing decimals from equations. And the whole reason we do that is to make our equations easier to solve. So let's start with combining like terms. So in both of these, there's more than two steps, unlike the ones we did yesterday, because we have to combine stuff first. So when I look at this first one, I see that on the left side of my equation, I have two x's. So we can combine those. 3x's minus 4x's is going to give us negative 1x plus 6 equals negative 2. And now it looks just like the two-step equations. We have to undo PEMDAS, so undo addition and subtraction first. So I get negative 1x equals a negative 8. And then to get x by itself, we want to undo this multiplying by negative 1. So we end up with x equals positive 8. And remember, just like the other ones, you can go back and plug this in and double check that it works. So if we do 3 times 8 minus 4 times 8, add 6 to it, we can see if we get negative 2. And 3 times 8 is 24, minus 32 plus 6. If you type that in your calculator, you definitely get negative 2. So now the next one is almost the same, except things are on the right side instead of the left. But still, we see that we have something we can combine. So you always want to combine stuff before you start going, moving stuff from one side of the equal sign to the other. So when we combine those, 4m's minus 2m's gives us 2m's. And then undo PEMDAS. So we're going to subtract 1 from both sides. This crosses off. Remember, it really gives us 0. And then we're going to divide by 2. Remember, this really gives us a 1. So we end up with m equaling 3. And just like the other one, you can plug it in to check to make sure that your answer is correct. So now using the distributive property, just like the last ones, you want to simplify both sides of your equal sign before you start moving stuff on opposite sides of the equal sign. So when you look at one like a, you want to get rid of those parentheses before you do anything else. And you can actually solve this in a variety of ways, but I found the easiest is to distribute. So we end up with 3k plus 24 equals 21. And then solve it just like all the other ones. We'll undo the addition and subtraction first. Subtract 24 from both sides, so we end up with 3k's equals a negative 3. And then to undo this multiplication, we want to do some division. So k gives us a negative 1. And the awesome thing about solving is you can always plug them back in and check every single time. So if we have negative 1 for k, we can quickly see that inside these parentheses gives us 7, and we know 3 times 7 is definitely 21. So now the next one kind of has a lot going on. I know it's very tempting to combine those, but remember, we need to simplify first. So we have to follow PEMDAS, which means we have to get rid of those parentheses. So we got to do some multiplication first. So this 15 stays exactly the same. I'm going to distribute the negative 3, and be careful here, negative 3 times negative 1 is positive 3. And then we still have this plus 9 out here. So we still have to combine stuff before we can start moving stuff from one side to the other. So I'm going to add up this 3 and 9 to give me 12. And now I can start moving stuff on different sides. So we can subtract 12 from both sides. We end up with 3 equals a negative 3x. And actually, it's going to look very similar to the last one. Divide by negative 3. We end up with negative 1 being x. And like I said before, you should know at the end of a test or a quiz if you are getting the correct answers or not, because you can plug it back in and double check it. Now here's some of the hard stuff. Clearing fractions. Now if I was to give you a problem like this, most of you would look at it and go, it looks really hard. So you can solve this two different ways. this first way over here, you could add fractions up. So remember, you need common denominators in order to do that. So we made a 3 and a 2 into a 6. We combined the like terms to get us this 7/6. And then we multiplied by the reciprocal like we did with the one-step equations. It crossed off. We ended up with our nice pretty answer. There's an easier way to do this though. You can do something called clearing fractions, which means get rid of your fractions. So what you do is you look at all your denominators, 3, 2, and this guy has a denominator of 1. And you find a number that they all fit into. So 3 fits into, 2 fits into, and 1 fits into. And that magic number is 6. You could also use 12, since 3 goes into 12 evenly and 2 goes into 12 evenly. But 6 is smaller, so it's going to make our lives easier. And what you do is you multiply everything in the equation by that. We can use the multiplicative property of equality that says it doesn't matter what you multiply by as long as you multiply everything by it. And then something magical happens here. If you multiply 6 times 2/3, this crosses off and gives you 2. So 2 times 2 gives us 4. This right here, 6 divided by 2 gives you 3. So we get 3x. And then 6 times 7 is just normal multiplication. And then this equation right here is 300 times easier to solve than the one we started with, but they are exactly the same equation. We will get exactly the same answer when we solve them. So let's try one on our own. M divided by 4 plus M divided by 2 equals 5/8. So you look at all your denominators, 4, 2, and 8, and find a number that they all fit into. You could use 16, but 8 is smaller, so that's going to make our life easier. So what I'm going to do is I'm going to multiply everything by 8. And then do some simplifying. 8 divided by 4 is really 2, so this is 2m. And then 8 divided by 2 is really 4, so this is 4m. And then this here is like 5 times 8 divided by 8, so those just cross off and give me 5. And now, it doesn't take much at all to solve this equation. 4m plus 2m is going to give me 6m's equal 5. And if I divide both sides by 6, I get the m has to be 5/6. So now for the next one, we can do the same thing. Look at all your denominators. 3, 8, and then 26 has a denominator of 1, even though we don't see it. So you want to find the smallest number that you can think of that those fit into. So 3 doesn't fit into 8. 8's next multiple is 16. 3 doesn't fit into that. But the next one's 24, and 3 does fit into that. So what I'm going to do is I'm going to multiply everything by 24. And then 24 divided by 3 here is going to give me 8. So you end up with 8 times 2 times x, which is 16x. And then this next one, multiplied by 24, 24 divided by 8 is 3. So you end up, don't forget this negative, 3 times 5 times x gives you negative 15x. And then 26 times 24, you don't have to cross anything off since its denominator was 1. We end up with 624. And now it's really easy to solve this. 16x minus 15x is going to give us 1x. And that equals 624. And we know that 1 times x is really just x. So there's our answer, 624. We can do the same thing with decimals. Remember, decimals are just something divided by a power of 10. So, like if you have 0.5, that's really 5 divided by 10. Or 0.55, that's really 55 divided by 100. Or 0.555 is really 555 divided by 1,000. So remember, this is the tenths place because there's a 10 in the denominator. This is the hundredths place because there's 100. thousandths because there's 1,000. You can also think of it, there's one number after the decimal and 1 0. Two numbers after the decimal, 2 zeros. Three numbers, 3 zeros. So what you're going to do is you're going to look at your equation, just like we looked at the denominators, and find the most numbers after the decimal point. So this has 1, this has 2, and this has 2. So the most numbers I have are 2. So I want to multiply each side by 10 to the second power because of that, or we can just say 100. And something magical happens when you multiply this stuff by 100. Your decimals go away. And when that happens, you end up with a nice, pretty equation that doesn't take much work to solve. I know those numbers are a little large, but it's much better than working with decimals. So let's try one. Let's do B. When we look at this, we have 1, 1, 1, and 1. So all of them have one number after the decimal. So that means I'm going to multiply them by 10 to the first power, or just 10. And I'm going to multiply everything by 10. And remember, when you multiply something by 10, all you're really doing is changing where the decimal place is. 1.2 suddenly becomes 12 x's. 3.6 becomes 36. 0.3 becomes plain old 3. And 2.4 becomes 24. So now this equation looks way better, way easier to solve. We're going to use the same tactics that we did earlier and combine our like terms. So we get 15x minus 36 equals 24. And then undo the subtraction first. So we get 15x equals 60. And then undo the multiplication. So we get that x is 4. And just like every other thing we've ever done, you can plug that back in and check it. You can plug it back into the original equation and make sure you did it correctly. So, can you use the distributive property when combining like terms? Can you use the distributive property when solving? Can you clear fractions and decimals? I want you to go back and solve the equation that I did not. This one right here. That's your can you prove it. Make sure you write down any questions you have, and we can go over them in class tomorrow. Have a good night.